Hello again. So let's continue with techniques of integration. That's what we are doing in chapter 7. And let's summarize what we know so far. Number 1, from chapter 5, we know simple or direct. Just the integral of x is x squared over 2 plus a constant c. Just simple, direct, there is nothing else. Also from chapter 5, we know substitution. Now from chapter 7, we know so far by parts, and that was in 7.1. We know trigonometric integrals, and that was in 7.2. And let's summarize what we saw here. We saw sine only, or cosine only, or sine plus cosine in some form or another. We also saw tangent only, or only cotangent. Sorry, not cotangent, but secant. Or both. Tangent, secant. One second. Okay. So combinations or powers of tangent, powers of cotangent, or both. And again, here, sine and cosine, I'll say for consistency, the same thing, both. Okay. Now, we also looked at trigonometry. The next one is trigonometric substitutions, actually. So 7.3, trigonometric substitutions. What is next? So this is what we're going to talk about right this moment. But I would like to add here 7.4. What is 7.4? It's rational functions. The method of partial fraction decomposition for rational functions. Partial fraction decomposition. And one more, which will be in 7.6, basically tables, using tables of integrals. So this is what we are looking at in chapter 7. 7.1, 7.2, 7.3, 4, and 6. We do have, at the end of this chapter, improper integrals. So I'm going to add it here, improper integrals. And this is in 7.8. And that will be the entire chapter. Okay, so we are coming back to trigonometric substitutions. The way I like to present in trigonometric substitutions, so this is my page 2, is 7.3. I don't really like using those formulas. I prefer remembering that x will be denoted or substituted by sine theta in the event we have something like 1 minus x squared. How come? Because 1 minus sine squared will end up being cosine. We will substitute x, replace x by tangent theta, as long as we have something like the square root of 1 plus x squared. Why? Because 1 plus tangent squared with the square root will give us secant theta. And the last one is x equals secant theta, and it will be used with something like the square root of x squared minus 1. Why? Because secant squared minus 1 is tangent squared. The square root of tangent squared will give us tangent theta. Of course, there are certain conditions that have to be fulfilled, right? Assuming all conditions for domain are fulfilled. So please remember that all conditions are fulfilled. Okay, so I'd like to look at a couple of examples. And there I'm selecting all of them from the list of recommended problems from the math department, by the math department. So 19 on 505. So we have the integral from x squared, the square root of x squared minus 9 divided by x cubed dx. So first of all, this square root, when we look at these three possibilities, it doesn't match this, it doesn't match this. It's close to this one, but not exactly because of this 9. So a little factoring and algebraic manipulation will take care of that. So how will we do this? The square root of x squared minus 9, I will factor under the square root 9. And you could say, how come? 9 is not a common factor. Sure, it isn't. But I can do this. 9 times x squared over 9 is x squared. 9 times negative 1 is negative 9. This is a product now. So I can take the square root of 9 and write 3. And the square root of x over 3, everything squared, because I want something squared, and minus 1. So then x over 3 will be exactly what I need, which is the secant theta. Okay, so then we let x over 3 equals secant theta, multiply both sides by 3, x equals 3 secant theta, dx will be 3, I differentiate secant theta, tangent theta d theta. And now I go back, the equal symbol with a square on top of it. It means I'm jumping over all this. And let's see what we have. Now, here's the numerator. It's already here. So it's 3. But what is this? It's secant squared minus 1. But secant squared minus 1 with a square root on top is tangent. So we have 3 tangent for the numerator, 3 tangent theta. Now I have to multiply by dx times 3 secant theta tangent theta d theta. So this was taken care of, this was taken care of, and now we talk about this. No problem. All I have to do is cube x. So everything divided by 3 to the third, 27. Secant to the third is secant to the third. So notice that the integral in x changed now into an integral in theta d theta. So now the function, let me push my lamp over there. So the integral changed into an integral from x, the integral in x, into an indefinite integral in theta, d theta, of course. Now let's try to simplify as much as possible and see what we get. If I can get to the next page. If not, what are we going to do? Okay. I am on page 3. Good. So let's see what we can simplify here. I am going to simplify a secant theta with a secant theta from the denominator. I'm going to multiply now 3 times 3 is 9, so 27 divided by 9 is 3. For now, I have 1/3 in front, and the integral from tangent squared divided by secant squared. Of course, d theta. So now let's analyze what we have here on the side. So tangent squared is sine squared theta over cosine squared theta, and secant squared is 1 over cosine squared theta. Copy the numerator, flip the denominator. So this whole thing is basically sine squared, nothing else. So this is 1/3, the integral from sine squared theta d theta. Good. Let's continue. Now, remember what we did in trigonometric integrals? We replaced sine squared by 1 minus cosine 2 theta divided by 2. And that's exactly what we are going to do next. So from here, I'm going to put a triangle, jump over all this, follow the triangle with the equal symbol in it. Okay, so I have 1/3. I'll replace this, so I will have 1/6 in front. The integral from 1 minus cosine 2 theta d theta. Let me move this out of the way. Okay, so then we have 1/6 theta minus sine 2 theta divided by 2. Of course, plus a constant c. When I differentiate theta, I get 1. When I differentiate sine theta, 2 theta over 2, I get cosine 2 theta times 2 simplified, and I get that. Okay, next. So this is 1/6 theta minus 1 over 12 sine 2 theta plus a constant c. Now remember, the integral was given to us in x. We cannot leave the answer in theta. Theta was our substitution to help us get to the answer. But now, look what we have started with. We have started with x over 3 equals secant theta, okay? Which means that somewhere on this planet, there is a right triangle with an angle theta. And let me copy that here. So x divided by 3 equals secant theta. Or if you want, you can write cosine theta equals 3 over x. So somewhere on this planet, there is a right triangle with an acute angle theta whose cosine is the adjacent over the hypotenuse. Cosine adjacent over the hypotenuse, which means that the other leg must be x squared minus 3, right? Squared, of course. So the square root of x squared minus 9. Good, so now we continue here. I'm going to put this time, I don't know, a circle. Jump over all this, follow the circle on page 4. Okay, so then here's what we have. 1/6 theta is, I apply arc secant, the inverse of secant to both sides. So arc secant x over 3. That's for theta, minus 1 over 12. I have to remember, and I'm going to write it here, that sine 2 theta equals 2 sine theta cosine theta. This is one of the double angle identities. So this will be times 2. Now sine theta is the opposite over the hypotenuse, times the square of x squared minus 9 divided by x, times cosine. Now with cosine we know it's 3 over x, so times 3 over x plus a constant c. And this is how we get back to x. It's not finished. I have to work on it a little bit, but I hope this is clear. So let's finish it up. Okay, so let's see what we have. So 1/6 arc secant x over 3. With parentheses or not, it's okay. So we have 3 and 2 is 6, and simplified with a 12, it's -1/2. And I have the square of x squared minus 9 divided by x squared plus a constant c. And this is final. I hope this one is clear. Let's move on to the next one. Let's look at 27 on the same page, 505. Good. We have the integral from 0 to 0.6, they say, from x squared divided by the square root of 9 minus 25x squared dx. Again, a little bit of algebra and algebraic manipulation will help us tremendously here. Of course, I'm going to start with the square root. The square root of 9 minus 25x squared. I have to have 1, as we already discussed, so I will factor out 9. So I have 1 minus 25x squared divided by 9. And you know the trick. There is 3 in front. And under the square root, I have now 1 minus 5x over 3, everything squared. So the 1 minus the quantity squared, so that's clearly sine. So 5x over 3 will be sine theta. Because 1 minus sine theta squared will be cosine squared theta, the square root, and this answer will end up being 3 cosine theta. Here. Okay, so then solve for x, multiply by 3/5. So x equals 3/5 sine theta. I need dx. dx is 3/5 cosine theta d theta. Good. So now I go back here. I'm going to box it in, follow the box, jump over all this, and let's see what we get. I'm on page 5. So I boxed it in, the integral. X, but I have to square it. It says x squared, so I have to square this. So I have 9 over 25. Sine squared. And now I have to multiply by dx, 3 over 5 times cosine theta d theta. And now again, the denominator, we already know it has to be 3, and it has to be cosine theta, because we had 5/3 x equals sine theta, and we get cosine theta. Now, when x is 0, sine of which angle is 0? The answer is 0. Okay, so the integral for theta starts at 0. Now, so I'll write it here. When x is 0, theta is 0. Now, when x is 0.6, then we have 5 times 0.6 divided by 3 equals sine theta. So let's see what we get here. So when I simplify by 3, I get 0.2. And when I multiply 5 by 0.2, I get 1. So sine theta equals 1 means theta equals pi over 2. So then the integral in theta is between 0 and pi over 2. This is a definite integral. We will not have to do this to go back to, where am I? Here. To go back to the given variable. There is no need. And please don't do that. We do not need to go back. This is a definite integral. Good. So then let's continue. And let's see what we can do here. This cosine with this cosine will go away. 9 over 25 multiplied by 3 over 5. And this is 3 over 1 times 1 over 3. The integral from 0 to pi over 2. Again, of sine squared, there is nothing else. Everything else is gone. Again, 1 minus cosine 2 theta over 2 d theta, as we just had a minute ago. So this will be 9 over 125 multiplied by 1/2. The integral from 0 to pi over 2 from 1 minus cosine 2 theta d theta. So this is 9 over 250. The integral from 1, that is theta, from 0 to pi over 2, minus sine 2 theta over 2, again from 0 to pi over 2. Okay, so 9 over 250. We plug in pi over 2. When I plug in 0, I get 0. And here, when I plug in pi over 2, 2 times pi over 2 is pi, sine is 0. So the answer is 0. When I plug in 0, I also get 0. So this is 9 pi over 500. And I'll sub here and